Welcome to Robominions.in AI interview preparation app. The topic of this video is priority queues. So let's see the implementation of priority queue using array. So before continuing with the video, I would request you to watch this video on your laptop or a bigger screen because the code may not be visible on a smaller screen. So we will be tracing through the code and see how each section of the code works. So it is best to watch this video on a bigger screen or a laptop, and you can trace the code along with me. And I'd also request you to download the app Robominions.in AI interview preparation app. So this app is available in the website Robominions.in. So link is in the description. You can go and download the latest version here. So let's continue with our topic. We have today's topic, implementing priority queue using array. So let's start tracing the code. First we have, you need to see that we have an arrow for every stage of the code. So we are tracing using the arrow. So we have a hash include stdi.h, then hash define, we are defining a min macro with the minus 999. So that is the minimum value we are initializing with. Then we have a type def struct priority underscore queue renamed with priority underscore queue. So this is a structure where we have value and priority. So that is the structure of the priority queue we are creating. Using that type def, we are creating array of structures with six structures. So each of those values, value and priority, are garbage in this structure. So we have a queue data, that is value and priority, index. The index is the index number of the structure, and the address of that structure. So it is an array of structure. Then so you have to follow this convention in the side here. Okay. Then we have int size equal to -1 and peak index equal to -1. Okay. Then we have we go to wired main. So here is the main. Then we enqueue the data here. 22 is enqueued with the priority. We are giving priority as 1. So that is the priority. So let's go to the enqueue function. So it goes to enqueue function. Here initially the size was equal to -1, right? Now size is incremented, so it will become 0 here. You can see. Then we have queue of 0 dot value. So q, because size is 0 right now, so q of 0 dot value is equal to value. So the value we have passed is 22. So 22 has been added. Then we are adding the priority. So priority we have sent is 1. So 22 and 1 has been enqueued into the has been added to the queue. Then it comes out of the enqueue function. It goes to the next enqueue, which is called, that is 54 comma 3. 54 is the value and 3 is the priority. So let's see enqueue. Again size is incremented first. So size is 1 now. Then we have queue of 1. So queue of 1 dot value, 54 is added. Then we add the priority. Okay. And comes out of the enqueue function. Then next enqueue is called with value 40 and priority 4. Okay. Goes to the enqueue function. Size is incremented. Size is 2 now. So queue of 2 dot value equal to value. So value is 40. Then we have queue of 2 dot priority. Priority is 4. So 4 has been added. So you can see how our values are getting added to the queue and priorities are getting updated. Comes out of the enqueue function. Then goes to 30, another enqueue, 33 comma 2. Again size is incremented to 3. 33 is added. Priority 2 is added. Comes out of the enqueue function. Again goes to the enqueue function here. So 63 comma 4 goes to the enqueue function. Size is incremented to 4. Queue of 4, value is 63. Priority is 4. Comes out of the enqueue function. Okay. So this many. So totally we have called 5 times enqueue. The size of the size is 6. That is total number of structures, queue structures are 6. In that we have filled with 5. So then we have you need to observe that in the enqueue there is no queue full option. So it may go to a invalid spot. So you need to be careful. That is a bug in the code. You have to add your own fix for this. That if in case if you add more NQ and it goes beyond the queue size, then beyond the valid size, because we have 6 queue data queue uh, uh, array size of the struct, right? So that is 6 valid spots. But if you go to 7, then 7th is a invalid spot. So that checking had to be done. So that is missing here. You need to add it on your code. Okay. So now let's come back to the DQ. So call the DQ function. So DQ is called, in that there is a peak. So you have to check the value in the queue, the priority value, right? So it checks for the priority which has the highest priority. Okay, so let's go. It goes to the peak function is called. So we go to the peak. So here it goes to int highest priority is equal to min value. So right now highest priority is equal to -999. It has a minimum value. Then we have peak underscore index equal to -1. Okay. So then we have for int I equal to 0, I less than or equal to size, I plus plus. So I is 0, 0 less than or equal to size is 4. So 0 less than or equal to 4 is true, comes inside the for loop. We have if condition, if highest priority equal to q of 0 dot priority. So highest priority is right now -999 and q of 0 dot priority is 1. So both are not equal, so that is false. So let's also check for another ampersand peak index greater than -1. Peak index right now is -1, it is not, so that is also false. Then q of peak index -1 is a invalid spot, so there itself is gone. So this condition is false, doesn't go there. It goes to else if we have highest priority less than q of 0 dot priority. So -99 less than 1 is true. So highest priority is changed to q of 0 dot priority. So highest priority is 1. So this 1 is copied. Then we have peak index equal to I. So I is 0, right now. So I is 0. So 0 is copied to peak index. So comes out of the else if. Now I is incremented to 1. So 1 less than or equal to 4 is true. Now it goes highest priority equal to q of I. I is now 1. So it is a q of 1. You can see here. Dot priority. Priority is 3. So highest priority equal to 3. No, that is 1 is not equal to 3. That is false. Then we have peak index 0 greater than -1. That is true. Then we have q of 0 dot value. So dot value 22 less than q of 0 dot q of 1. Peak index is 0, I is 1, right? So 22 less than 54 is true. Since this first one is false, and true will all lead to, that is false and true and true is a false, because in AND operation we have false and true is a false. So comes to the else if. So now highest priority is, so we right now have 1, right? And this present priority, that is q of 1 dot priority is 3. So 1 less than 3 is true. So highest priority now changes to 3. Then we have peak index equal to 1. So peak underscore index equal to 1. Now I is incremented. Again we go to the for loop. I is incremented. Now 2 less than or equal to 4 is true. Now we have highest priority, that is 3, equal to q of 2 dot priority. Now q of 2 is, priority is 4. 3 equal to 4 is false. And we have peak index 1 greater than -1 is true. Then q of 1 is 54 less than q of 2, that is I. 54 less than 40 is false. So false, true, false is a false with the AND operation. Comes to the else part. Here the priority is 4 and highest priority is 3. 3 less than 4 is true. So highest priority has been changed to 4 now. Okay. Now we have peak index as 2. So because peak index equal to I is 2 right now. Comes out of the else if, comes out of the, so I is incremented. Now for loop has 3 less than or equal to 4, true. Now again highest priority is 4 right now. 4 equal to q of 3 priority is 2 here. So the 2 value. So 4 equal to 2 is false. Okay. Peak index greater than -1, 2 greater than -1 is true. Then q of 2 dot value, q of 2 is 44, 44 less than 33, q of I is 3. So q of 3, so that is 33, 40 less than 33 is false. So false, true and false is false. Comes to the else part, here 4 less than 2 is false. So the priority is false. So highest priority, it doesn't go into the else condition, so it doesn't go inside this, comes out. I is incremented. 4 less than 4 less than or equal to 4 is true. So comes inside. Now now you can see we have I as 4. Q of 4 has a priority 4. Now highest priority is 4. Q of 4 dot priority, 4 equal to 4 is true, and peak index is right now 2. 2 greater than -1, 2 greater than -1 is true, and q of 2, q of 2 dot value, q of 2 is 40. So q of 2 40, 40 less than or equal to q of I is 4, 63. Q of I dot value 63. 40 less than 63, that is also true. So all three conditions in with the ampersand are true. So it goes inside the if condition. Now highest priority equal to q of 4 dot priority. So it is 4. So this 4 again is it remains 4. Then peak index equal to 4. Okay. So we have, so you need to remember peak index is a global variable. So the global variable remains. Okay. And int size also is a global variable. So even that remains. So it comes out of the if condition. I is incremented now. 5 less than or equal to 4, false. Okay. Comes out of the for loop, comes out of the peak function. So once it comes out of this function, the highest priority variable, it was the scope of that variable was inside this function. So it is gone, but the two global variables remain. So this will be used here. Now you can see peak index right now is 4. 4 equal to -1, false. Comes to the else part. For int I equal to peak index, so I is 4, size is also 4. 4 less than 4, false. So doesn't go inside the for loop, comes, decrements the size. Size is decremented to 3. So this now, once the size is decremented, this value is now considered as a garbage value. So that is why we have G. G stands for garbage value. So priority and value is considered as garbage. It comes out of the else condition, comes out of the dequeue function. So successfully the value has been dequeued. Okay. Now again another dequeue is called, let's see, goes to the peak function again. So it's same repeat. Now highest priority equal to -999. Peak index now has been reassigned with -1. Goes to the for loop. We have int I equal to 0, 0 less than or equal to 3. The size is 3 now. You can see here. It is true. Goes to the highest priority equal to q of 0 dot priority. You can see 99 minus 999 is not equal to 22. -1 greater than -1 is false. Q of peak index of -1, that is an invalid location, so it remains false. Comes to the else if, -999 less than 1 is true. So highest priority is gets the value of 1 here. So highest priority is q of 0 dot priority. Q of 0 is this one, 1 is copied. Okay. Now peak underscore index equal to I. So I is right now 0, so 0 is been assigned. Comes out of the else if condition. I is incremented, so go to the for loop. So I has been incremented to 1, so 1 less than or equal to 3 is true. Now again, if highest priority equal to q of 1 dot priority, so q of 1 priority is 3, so highest priority is right now 1. 1 equal to 3 is false. Peak index 0 greater than -1 is true. Q of 0 dot value, that is 22. Q of 0 is 22, less than or equal to q of I is right now pointing to 1. So 22 less than 54 is true, but since the first is false and the others are and, so it remains false. Comes to the else if part. Now highest priority 1, so highest priority right now is 1, and q of I is 1, so q of 1 here, as we can see, it's already pointing. So the priority is 3. 1 less than 3 is true, so goes highest priority is reassigned with this priority value. So highest priority is now 3. Peak index is 1. Peak index equal to I, that is 1. It's true. Okay. Now comes out of the else if. I is incremented. In the for loop, we can see I is turned now to 2 less than or equal to 3 is true. Now again, highest priority is 3. 3 equal to 4. So q of 2, that is I is 2, right? So q of 2 is pointing to this. So here you can see the priority. Highest priority 3 equal to 4 is false. Peak index, by just going back, we can see, yeah, just went back. Now peak index 1 greater than -1 is true. Q of 1, 54, Q of 1 is 54 value, has a 54 value, and Q of 2 dot value is 40. 54 less than 40 is a false. So false, true, false is a false. Okay. Comes to the else if part. Now you have highest priority 3 and the priority here is 4. 3 less than 4 is true. So comes inside highest priority equal to q of 2 dot priority. So now highest priority becomes 4, has turned 4. Now I will become, I is 2, peak underscore index is 2. Okay. Comes out of the, now I is incremented. Now I has turned 3. 3 less than or equal to 3, true. So again highest priority is 4. 4 equal to priority here is 2, right? Q of 3, Q of I. So 4 equal to 2 is false. Peak index 2 greater than -1 is false. True. Q of 2 value is 40. 40 less than 33. 40 less than 30 is false. So it is false, true, false. So it becomes false. Comes to the else if. Highest priority less than, that is 4 less than 2. Because here we have priority 2, right? 4 less than 2 is false. So even that fails. Comes out, we have now I incremented to 4. So you can see I has been incremented to 4. 4 less than or equal to 3 is false. Comes out of the for loop. Comes back to the peak function here where it was called. Highest priority has been out of scope, gone. Now size equal to 3, peak index equal to 2 after finishing this function. So now it checks if peak index 2 is equal to -1, false. Comes to the else part. We have I equal to peak index, it is 2. 2 less than size, 2 less than 3 is true. Goes inside. You can see, just go back, keep watching. Here it is 40 and 4, right? Here it is 33 and 2. Q of I right now is 2 is equal to Q of I plus 1. So 2, Q of 2 equal to Q of 3. So 33 and 2 is copied to this. So you can see it has been copied, right? See 33 and 2. The reason is we are dequeuing 40 and 4 because 4 is the lowest priority value. 4 is the lowest priority. 40 is the lowest priority value. So we are copying this data to this location, and this index 3 will become garbage. So got it, right? So we are moving the data this side, and then we turn this garbage, successfully eliminating the low priority 40 value from the queue. So that is what is happening here. So you can see the data has been copied. Addresses are the same. The data is copied. Even index is remain the same. Data is copied. Now we decrement the size. Sorry, before that we increment I 3 less than 3 false. So comes out of the for loop. First we have to come out of the for loop. Then we decrement the size. Size is 2 now. This has turned garbage. So successfully deleted another low priority value using DQ. So comes out of the function DQ. So DQ successfully done. So now we have another DQ is called. Let's go back. So now we are at the void DQ function. So again we have called peak. So int peak. So right now size equal to 2. Peak index will be replaced. So you can see highest priority right now is equal to minus 999. Peak index has been replaced with minus 1. Now again we start with the size 2, right? So int I equal to 0, 0 less than or equal to size is 2. So 0 less than or equal to 2 is true. We go to if highest priority equal to q of 0 dot priority. So highest priority is minus 999. So q of 0 dot priority is 1. So priority value is 1. Peak index is right now minus 1. Minus 1, sorry, let's go back. So I was there, right? Yeah. So peak index minus 1 greater than minus 1. That is true. Q of peak index, Q of minus 1 is false. So sorry, minus 1 greater than minus 1 is actually false. Sorry. So all three conditions are false. So it is a false. Comes to the else if part. So here minus 999 less than 1 is true. So we have highest priority equal to q of I is 0, right? So q of 0, you can see here it is already pointing. So the priority value is 1. So highest priority is assigned with that value. Then it comes to the peak index, and peak index is assigned with I. I is right now 0. Okay. So that it comes out. So I is incremented now in the for loop. For I is 1, 1 less than or equal to 2 is true. Comes to the if condition. Highest priority right now is 1. 1 equal to q of 1. Q of 1 is pointing to this. So it has a priority 3. So 1 equal to 3 is false. Peak underscore index is 0 right now. You can see 0. 0 greater than minus 1 is true. Q of 0, because peak index is 0. The value is 22. 22 less than q of 1 value is 54. 22 less than 54 is true. So these two conditions are true, but highest priority equal to the priority value is not true. So false and true and true is false itself. So it is false in the if condition. Comes to the else if. Here highest priority less than q of 1, because I is 1. So q of 1 dot priority. So highest priority is 1. 1 less than q of 1 priority is 3. So 1 less than 3 is true. So comes inside the if condition. Highest priority equal to q of 1 dot priority. So the 3 value has been replaced. So highest priority equal to 3. Then we have peak index equal to peak underscore index equal to I. I right now is 1. So peak underscore index is 1. Comes out of the else if condition. Now I is incremented in the for loop. So for loop 2 less than or equal to 2 is true. So then it goes inside the for loop. Now if highest underscore priority equal to, so highest priority is 3. 3 equal to q of I is 2 now. Q of 2 dot priority. Priority is 2. So highest priority 3. 3 equal to 2 is false. Peak index 1 greater than minus 1 is true. Q of peak index, Q of 1 value is 54 less than 33 is false. So false, true, false is false. So it comes to the else if part. Here we have highest priority 3 less than 2, that is q of 2 priority is 2. So 3 less than 2 is false. So it doesn't go inside that condition. Comes out. Now I is incremented. So I is incremented. So 3 less than or equal to 2 is false. Comes out of the for loop. So we have size equal to 2, peak index equal to 1 right now. So once it comes out of the function, so we have size equal to 2, peak index equal to 1. So 1, so here peak index 1 equal to minus 1 is false. So doesn't go inside the if condition. Comes to the else part. Now we have I equal to 1 and size is 2, right? So 1 I equal to 1 because peak index is 1. So 1 less than 2 is true. So now you can see so what we are trying to do now. So we are trying to DQ, right? DQ which value? So among these three values, who has the least priority? So least priority is 54 because the priority value is 3. So 3 is considered a least priority. So now you can see for Q of I is 1 and Q of 1 plus 1. So 2. So 33 is copied to this. I'll go back. You can see I can go back. So here you can see I'll click next now. So you can see 54 and value 54 and priority 3 is replaced by 33 and 2. So once I click next, you can see here. Okay. So this has been copied. Now I is incremented here. 2 less than 2 is false. Okay. Now it comes out of the for loop and size is decremented. Size is decremented to 1. This has turned the garbage value. Successfully removed another value with a low priority value. Okay. Comes out of the DQ function. Okay. Now we have already DQ'd 3 values. Now another DQ is called. It goes to DQ function. Now again peak function is called. Let's trace it once again. It will be a little shorter now because the size of the queue is small, right? So goes to the peak. Highest priority equal to minus 999. Peak index equal to minus 1 now. For I equal to 0, 0 less than or equal to 1 because size is 1 right now. So it goes highest priority minus 999 equal to priority of q of 0 is 1. It is not, it is false. Peak index minus 1 greater than minus 1 is false. Q of peak index of q of minus 1 is an invalid location. It is false. Comes to the else if. Highest priority minus 999 less than 1 is true. Goes inside the if condition. Now highest priority has been replaced with value 1. So that is correct. Peak index equal to 0 right now because peak index equal to I is right now 0. Comes out of the else if. I is incremented in the for loop. So now I is 1 less than or equal to 1, true. Goes to the if condition again. If highest priority, so 1 equal to 2 because highest priority is 1. 1 equal to 2 is false. 0 greater than peak index 0 greater than minus 1 is true. Q of peak index, that is q of 0. Q of 0 is 22 value. Q of 0 dot value is 22. See, you have the index here. And 22 less than q of 1 dot value. Q of 1 value is 33. 22 less than 33 is true. It is like false and true and true. So it is false. Comes to the else if part. So now we have highest priority 1 and the priority of this is 2. So 1 less than 2 is true. Highest priority is replaced with lower priority value 2. Okay. Now peak index. So peak index equal to one more thing. I just realized that highest priority. So the bigger the value, that is the highest priority. Highest priority values are dequeued from the queue. Okay. So I just I realized that a few minutes back I made a small mistake while dequeuing here in this part of the code. So just correcting, we are trying to remove highest priority values. Okay, coming back to the code. Now peak index equal to I. I is right now 1. So peak underscore index becomes 1. Comes out of the else if condition. Now again I is incremented. 2 less than or equal to 1 is false. Comes out of the for loop. Comes out of the peak function. Here we have size equal to 1, peak index equal to 1. So comes to the else part now. So for I equal to 1, peak index is 1, size is 1. So 1 less than 1 is false. So we directly, so this is 2 is a highest priority, right? 2 is a bigger, considered as bigger priority. So that is removed first. So we decrement the size and this turns a garbage value. So now only 22, 1 is left. So comes out of the dequeue function, then goes another dequeue function is called, you can see here. So goes to the peak function again. So in the peak function now size is 0, right? So highest priority is minus 999, peak index is minus 1. Now for int I equal to 0, 0 less than or equal to 0 is true, goes inside. Highest priority minus 999 equal to 1 is false, comes to the else if. Minus 999 less than 1 is true, highest priority is assigned with value 1, peak index is assigned with value 0, comes out of the else if. I is incremented. Once I is incremented, 1 less than or equal to 0 is false, comes out of the for loop, comes out of the peak function, goes back to here. If peak index equal to minus 1, 0 equal to, because peak index right now is 0, it is false, comes to the else part. For I equal to peak index, I is 0, size is 0. 0 less than 0 is false, doesn't go inside the for loop. Size is decremented. Now size is minus 1 and this the value here has been turned garbage. So successfully dequeued. So comes out of the dequeue function. Now 1 again dequeue is called, it goes there, it goes to the peak function again. Now you can see it goes peak function again, highest priority is called, peak is minus 1. Now here int I equal to 0, 0 less than or equal to size is minus 1. So it doesn't go inside the for loop, directly comes out of the for loop, doesn't go inside, so directly out and then out of the peak function. Now right now peak index is minus 1. So if peak index equal to minus 1, minus 1 equal to minus 1 is true. So it means queue is empty, successfully emptied the queue. Queue is empty, comes out of the if condition, comes out of the dequeue function and successfully comes out of the wired function, wired main function. The time complexity is order of n as we are iterating through all the queue elements to check the priority values, right? So that is why the time complexity is order of n. Okay, try to watch this video again to understand the implementation of priority queue. And if you want to access the code here, you can click on the code button. And just in case after watching the video, if you are still doubtful with the concept, I request you to download the app Robominions.in AI interview prep app. Once you have this app, you can trace the code yourself with a click of back and next button. So it's very simple. So you can this priority queue is a very much asked in many interviews. You can just trace the code yourself before going to interview or before going to exam. You can just click back and next button and slowly try to understand it. You just spend a couple of hours once, then it will be very easy to revise. You have a clear picture of how this is happening. So how the peak index, how these functions are working, each function. Then you can try to write the code yourself on a piece of paper and try to analyze the code. You write a pseudo code yourself and then you get a clear understanding. So before interview, you can quickly revise this. So I request you to download this app, and it's available on the website robominions.in, and download the latest version here. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app. and make your coding easy. Thank you for watching this video. Bye.